Hello students, how are you all? I hope you are doing well at your home, you are doing studies at your home and you are staying safe. I am Vikas Monaker, PGT Physics from Kendriya Vidyalaya Lansdowne, and today we will study chapter 8 of class 12th physics named Electromagnetic Waves. This is the lecture number 1. In this lecture, we will study about the introduction, electromagnetic waves, displacement current, the concept of displacement current and its formula. We will study the modified form of Ampere circuital law, the properties of electromagnetic waves, and at last, in this lecture, we will study about Hertz experiment. So, initially, before beginning the contents, I'll tell you about the contents. Before we start the chapter in detail, I'll tell you about the syllabus related to this unit number 5 or chapter number 8, electromagnetic waves. It consists of following topics. First, basic idea of displacement current, electromagnetic waves, their properties and characteristics, their transverse nature. In the second part, we will study about electromagnetic spectrum and about electromagnetic waves like radio waves, microwaves, infrared waves, visible rays, UV rays, X-rays, gamma rays, including their elementary effects and their uses and information about their source. So these are the things that is covered in our syllabus. So we will study these things under different lectures. So we will start with the first part, that is electromagnetic wave. Electromagnetic wave is the wave that is radiated by an accelerated charge. An accelerated charge produces electric field, which is changing, which produces the magnetic field. So a wave is produced through the space in the coupled form of electric and magnetic field, in such a way that electric and magnetic field, they are perpendicular to the direction of propagation. So the wave is called electromagnetic wave. So with the coupled form, we can say that the time varying electric field produces space varying magnetic field, and a time varying magnetic field produces a space varying electric field with their equations. The propagation of electromagnetic wave through the space is fully described in terms of wave theory, but the interaction with the matter depends on the quantum theory. Here the electric and magnetic fields are the source to each other, because the electric field produces magnetic field and the magnetic field produces electric field. Here we are not discussing Maxwell equations, but in modified form it can be discussed. Electromagnetic wave is a wave in which electric field and magnetic field, they are right angle or they are perpendicular to each other, and as well as they are perpendicular to the direction of propagation. Now we will study about displacement current. Scientist Maxwell showed that the changing electric field or the changing electric flux produces a kind of current through the capacitor. So this current through the capacitor is known as displacement current. It is produced by the change in electric flux or change in electric field. The formula is displacement current ID equal to epsilon naught d phi e over dt, where phi is the electric flux. You can call d phi e over dt as rate of change of electric flux. So by the variation in electric flux, this displacement current is produced. Now we will study the concept of displacement current. What is the need of taking this into account? So for this we have to study Ampere circuital law, okay, and we have to make use of Ampere circuital law. Okay, so here we consider a capacitor which is connected to a power source along with a series switch. The current flows. Okay, we consider two loops C1 and C2. These are closed loops. These are very close to each other also. One loop is there, okay, in the left side of the first plate of the capacitor, and the second loop is there in between the plates of capacitor. So here the current is passing in the wire and the loop is enclosing. Okay, so we can apply Ampere circuital law for this loop C1. So line integral of magnetic field along this path C1, that will be equal to mu naught times I, where I be the conduction current. But if we apply the Ampere circuital law to this loop, then line integral of magnetic field along C2, that is equal to 0, because there is no conduction current. So this is assumed to be equation number 1, and this is considered as equation number 2. Now from equation number 1 and 2, okay, we can conclude, since C1 and C2, they are very close to each other, then their values should be equal. That means closed integration C1 b dot dl, that should be equal to C2 b dot dl. But their values are not equal, since for the first equation the value is mu naught times I. Okay, so the conduction current cannot be 0. So the Ampere circuital law seems to be inconsistent in this case. Therefore Maxwell postulated that there must be a particular current which is satisfying, which is existing in equation number 2 in order to make this equation correct. So the existence of displacement current comes into action, okay, which is given by the time varying electric field and produced by the variation in electric flux. Now how it is set up? The electric field in between the plate is given by sigma upon epsilon naught, and sigma is equal to q upon a epsilon naught. So if we differentiate this, we'll get 1 upon a epsilon naught dq. It is q dq over dt. So value of dq over dt is obtained. So it is coming epsilon naught a de over dt. So when we multiply a by e here, directly I am telling a by e, we get phi e. So if we place for the second condition closed integration b dot dl, instead of 0 mu naught into id, okay, then this id is the displacement current. Then the value of displacement current is epsilon naught d phi e by dt. This is mu naught into, this is epsilon naught d phi e over dt. So the modified form of Ampere circuital law is line integral of magnetic field along closed path, that is mu naught times I plus id, or you can call it IC plus id, okay, where ID be the displacement current, its value is epsilon naught A, epsilon naught A dE over dt, or epsilon naught d phi E over dt. So that's how the displacement current can be set up. Now we study the properties of electromagnetic waves. The properties of electromagnetic waves are as follows. They are in same phase. Electric field and magnetic field, they are in same phase. So they attain the maximum and minimum value at the same place and at the same time. You see in this diagram, electric field is maximum here along y-axis, and here magnetic field is maximum at the same time along z-axis, which is along z-axis. The direction of electric and magnetic field, they are mutually perpendicular to each other, as well as the direction of propagation. The electric field vector and the magnetic field vector, they are related by the equation C equal to E naught over B naught, where E naught is the peak value of electric field, B naught is the peak value of magnetic field, and C is the speed of light. The velocity of electromagnetic waves in the free space is given as C equals 1 upon under root mu naught epsilon naught. And in the medium it is given as 1 upon under root mu epsilon, where mu and epsilon are absolute permeability and absolute permittivity of the material medium, and for the free space they are mu naught and epsilon naught. Electromagnetic wave obeys the principle of superposition. They carry energy as they propagate to the space. This energy is shared, or this energy is divided equally in between electric field and magnetic field. Electromagnetic waves can transfer energy as well as momentum to the objects placed to their path or on their paths. For the discussion of optical effects of electromagnetic waves, more significance is given to the electric field. Therefore, this is called light vector. Electromagnetic waves, they do not require any material medium for their propagation. An oscillating charge which has non-zero acceleration, it can produce electromagnetic waves, because the oscillating charge with non-zero acceleration, that can produce electricity. Now Hertz was the first one to demonstrate the production of electromagnetic waves in the lab, which is based on the principle that a vibrating charge radiates electromagnetic waves. He used oscillatory LC circuit to produce electromagnetic waves. The transmitter consists of two large square metal plates. These are placed in the same vertical planes with their center separated by few centimeters apart. The plates are connected to the thick wires ending in highly polished brass spheres. The distance between the two spheres is nearly 2 to 3 centimeters. Two thick wires, they are connected with the secondary terminals of the induction coil. Every time when current in the primary circuit of the induction coil is interrupted, large potential difference is set up across these S1 and S2, and these metal plates gets charged. High potential difference is set up that ionizes the air gap and makes the gap conducting. The electrons and ions produced oscillate back and forth across the gap S1 and S2, and oscillating discharge of the plates occurs through the gap. This process results in the production of electromagnetic waves. You can see electromagnetic waves are generated. The frequency of the electromagnetic waves is given by nu equal to 1 upon 2 pi under root LC. The receiver or detector consists of almost closed circular wire terminating at the two ends with the two polished brass spheres. There you can see S1 and S2. The electric field associated with the EM wave set up the high potential difference across the gap in between S1 and S2. This called tiny sparks jumping across the gap. This proves the existence of electromagnetic waves. So the spark here produced here proves the existence of electromagnetic waves. So that's how Hertz initially or first in the laboratory produces electromagnetic wave with this simple arrangement. So that's all about Hertz experiment. Thank you.